All righty. Hello, everybody. We're going to give it just another minute here before we officially kick off, but wanted to go ahead and start the broadcast since we are, after all, at time. So I see a bunch of people rolling in, so give it another minute or two. So Sam, I have a question behind you. I think I see. Yeah, I see your. Yeah, what's the picture behind you? Is that like?
It's just a banner.
Not your banner. The picture. The painting.
Oh, is that? I don't know. Greg just put it in my office today, so.
Ah.
I think it's basically just like a wooded lane.
It's just.
Like the dot.
I see a lot of dots, and so it's like it was very point cloud-esque, but not point cloud-y. So
yeah, that's a good point.
I feel like a little bit of like the cherry trees in Washington D.C.
Yeah, a little pointillism back there. Cool stuff. Well, let's go ahead and kick off, y'all. I think we're 3 minutes in. I don't want to wait anymore. I still see a bunch of people rolling in, but we will roll. See Scott Scott Lochner says hi, one of our regular attendees. Hi, Scott. And Dan has asked how he gets a Scandibim University t-shirt, and we are constantly trolling our lists looking for people who've attended a bunch of these and sent them to him. Scott, I think we've sent one to you finally, by the way. So Dan, if you showed up to a bunch of them, you might find one in your mailbox eventually, or at least ask for a size in your email inbox. So keep an eye out for that. It's an incentive to not mark our marketing email as spam, because if you mark our marketing email as spam, when they reach out to you to ask for your t-shirt size, you won't see it. So if you want swag, make sure to whitelist our marketing email.
Do you know when somebody marks your email as a spam?
Nope, we don't know.
Oh, we don't. Oh,
no idea. But sometimes they just go into a black hole. But yeah. Anyway, let's get going with the official content. So today we are going to talk about deliverables and trying to make sure we have a happy customer. We have with us our wonderful. Oh, it helps if I hit the right button here. Boom. There we go. We have our wonderful host panelists here with us today. We're missing one panelist who couldn't make it, so we'll make fun of him a little bit, but that's all right. Quick housekeeping, everybody's muted. Ask questions via the questions panel. That's how Scott and Dan have already asked questions. We do keep an eye on those throughout, so if something pops up that's relevant to the topic we're on, we'll go ahead and answer it on the fly. If we don't get to it on the fly, we will do it at the end. We typically wrap the kind of panelist portion very close to the end of the hour because we pack a lot of content into these. So we usually run Q&A long. So we'll probably stick around 15, 20 minutes afterwards, just going through the questions and answering stuff. Don't feel obligated to stick on for that. All of this is recorded. So if you asked a question, you can probably watch the recording and hear the answer. We'll also try and follow up afterwards. Sylvie with RC Monkeys is our Q&A maestro for Scandibim University. So he has been cranking through questions and posting them, giving them to us. And we're posting them on the LinkedIn channel.
A lot of fun.
Yep, a couple a week. So that's another mechanism you might get them answered as well. So keep an eye on the LinkedIn group for Scandibim University. Yeah, and anybody that's registered will get a link to the recording. So with that, let's stop talking about webinar housekeeping. Sam, you want to start out by introducing yourself?
Sure. My name's Sam. We live in Rochester, that's where Hale Tip is based out of. So work at Hale Technology and Practice in Rochester. My focus is on scanning and scan-to-BIM projects. And we also do a lot of VDC work and clash coordination and that kind of stuff as well. guess just kind of run through my little fun notes. I am in NAWIC, National Association of Women in Construction, as well as Women in BIM. Tell all of your lady friends to join, because we need more. And I've seen the band Walk the Moon in concert over 10 times. And last time I said I was a Bills fan, and I got a boo Bills, so I'm gonna keep up. Go Bills.
Go Bills. Go Bills. Okay. Yeah, I don't know about that, but I don't know. I think we joked about this last week in the prep call, but I think we need to start a ladies in LiDAR subgroup of women in BIM because, yeah. Anyway, Mark LaBelle, I really wanted to have on this session. I'd been planning to have him on this session for like 6 months, and then he took a very ill-timed personal vacation. And so rather than just hide him, I'm instead going to mock him and say that he should have been here because SSOE does some really cool stuff with deliverables that they turn over to their clients, which we are not going to be able to show because Mark's not here to talk about them. But by all means, if you're listening in, harass him on LinkedIn or Twitter or something, and he'll be happy to tell you all about it that way, or call him out on the ScandiBIM University LinkedIn group. Silviu, since you are here.
Yeah. All right. So Silviu Stoyan, running RC Monkeys. And I've been in the AEC industry since 2005, started on the field and then transitioned with the back group in the office. And I was introduced to BIM and laser scanning about 10, 11 years ago. So since then, I've been doing hundreds of projects, mostly in the building documentation realm. So right now, RC Monkeys, it is specialized in building documentation. That's scanning, creating 3D models, virtual mock-ups, and also various types of analysis involving point clouds. So that's about everything in a nutshell.
Random personal fact I know about Silviu: he started smoking when he was 9 and quit when he was 13.
Yeah.
Or something. Yeah.
Yeah, you got to try it while you're young.
Eastern Europe.
Yeah.
Yeah. And I am the host today and every day at ScandiBIM University. Been doing ScandiBIM, BIM, VDC, all sorts of stuff for the past, 15 years now. Yeah, play guitar. I'm not going to be playing guitar today though. So I did just get a new bass. It's hanging on the wall over there. You can probably see it. But nobody has bribed me sufficiently to play guitar on one of these webinars yet. So otherwise, anybody that's been to one of these knows me. So let's get going. Now, before we dive into this, Silviu, I know you had an anecdote you wanted to share. I've got one. Sam's got one, I'm sure. So just as a quick intro, we talked about this a lot in other classes, but a key part of a successful project is actually understanding what your client needs. And that applies to deliverables specifically as well, of course. And with that thought, Silviu, why don't you kick us off with your anecdote?
Yeah, so I was thinking about this today because we put a lot of effort in the delivering our projects. They're not easy, and sometimes we spend thousands of hours preparing something that hopefully will satisfy the needs of the client. So I was thinking about an anecdote that will describe some situations, not all the time, but this can happen. So think about a client meets with a consultant, and the consultant's trying to figure out what the problem is, what he's trying to solve, right? So the client says, I have a problem. I'm trying to get from point A to point B. Easy problem. The consultant thinks, oh, that's I've heard enough. I know the solution. I will provide you the most effective solution in about a month. The consultant comes back in about a month, and he says, here it is. This is the most effective way of getting from point A to point B. The client looks at it and he thinks, what is it? What is this? It's like, the consultant, obviously, it's an airplane. That's the most effective way of getting from point A to point B. And the client is a little bit upset because, he doesn't have any pilots to fly this airplane. So even though this is the most effective way to get from point A to point B, maybe your client doesn't see it that way. So you need to make sure that you understand the expertise of the client's team. So the first step in creating a deliverable is to start that conversation with the client. Ask a lot of questions. Your goal is to ask a lot of questions and listen. Identify the problem and then provide a solution. And maybe a deliverable might fit the needs of one client, but doesn't fit the needs of the next client. And a lot of time we tend to ask the client to define the specifications. And I would encourage against that. I would encourage you to ask those questions and understand the pains, understand the goals, and evaluate the expertise of his team. And then you, as an expert, you should be the one defining those project specifications. So to conclude, when you deliver a project, that project should be in line with the client's expertise, should obviously meet a certain schedule and a budget, and third, it addresses and solves their problem in a very clear manner. So that's my intro to this session, Kelly.
I loved it. Still love it. So that's yeah. It reminded me of I think the default fallback for a lot of consultants, particularly surveying firms that got into Scan-to-BIM, was to deliver a point cloud. And the reality is most of their customers didn't know what to do with it. And,
Exactly.
They were delivering it in a standard format like E57 or PTS or PTX or something like this. And it's like, here's this giant, 300 gigabyte file. There you go. And then it's like, what the heck do I do with this thing, as a customer? And so, I know back when you and I were practicing this at Beck, one of the things that we got in the habit of doing is we actually handed over a Revit model that had the point cloud already linked in, already indexed as an RCP and an RCS. So all they had to do was go into Revit, and link a Revit model in, and they got their stuff. And then they could look at it, or they could, and then they could reverse engineer because they could go into the link and they could see how the point cloud was loaded in and then load it in the same way in their main file if they wanted. As opposed to, here's a point cloud file, good luck. Figure out coordinates on your own, figure out this stuff on your own. So, Sam, what are your thoughts on this?
Yeah, I mean, I guess my first thought is you got to kind of read between the lines. So when you get an RFP or when you get an email from somebody asking for your work, they might say, hey, I need a scan. Well, I don't know what they actually need when they say they need a scan. So our first question is always, what are you trying to get to? Like what are you trying to do? Why do you need this information? Because it's not always a laser scan that is the best solution. We've got a wide variety of tools that we can use to get you the information you need. So we always kind of take a step back and ask them, what do you want it for? What are you going to be doing with it? What's your end goal? And then that's kind of where you start. And we are the experts, they're not necessarily. So we give them recommendations based on what they need to do with it, not necessarily what they think they want. So.
Yeah, and also Kelly, when you think about it, what we produce as a deliverable is just a tool. Is a tool to feed information to our clients, and clients make informed decisions. So we need to understand how that information is being consumed. Otherwise, the tool is useful.
Yeah.
Useless. Useless.
And understand where our expertise, understand that our expertise doesn't stop at the scanning. And so I think, if you haven't checked out our last class on modeling, on the actual process of modeling from scan data, one of the interesting things is, since nothing is actually built vertical or, 90 degrees to each other, since nothing's built perfectly, a big part of creating a Scan-to-BIM deliverable is figuring out how to rationalize what's actually built into something that's actually usable for a designer or for an engineer to do their work, for instance. And, you know, that might mean that you're actually intentionally modeling things not where the point cloud is, because the way you've already rationalized something else shifts it down. The wall, Sylvia, you mentioned this wall where the building was so out of square that on one end of the building, you know, the outside wall was shifted over like 6 inches. Well, that meant the inside wall needed to be shifted over 6 inches too, so that you actually had the right square footage in the room. And so just that kind of expertise, it takes time to learn, and our clients frequently don't have that. And so, you know, we can provide that expertise more than just the capture of the data, certainly. So with that, I think point well made. Let's talk about actual deliverables, and we are going to start with point clouds. I have point clouds pulled up. You know, I'm sorry I don't have a pretty picture on this slide, but you know, I've got an example up here that we can take a look at as needed. So when you're doing scanning, there's kind of a couple different types of formats that you typically get point cloud data in, right? Your scanner has a native format that it records data in. If it's, you know, Faro has their native format, Leica has their native format, Topcon has our native, everybody has their little native format. And these are, you know, highly efficient formats to try and minimize the processing on the hardware, get best battery life out of the scanner, et cetera, et cetera. And generally, not always, but generally, you're going to need something to interpret that and get it into a more generic format. And so that might be something like Recap, which will pull in a couple of different formats. Generally, it's, you know, your laser scanner manufacturer's software, which is going to handle that in the most efficient way, process it, structure it, you know, all the stuff that it needs to do in the most efficient way. And then we hear a lot of grief over this. There's structured and unstructured formats. People confuse this with registered and unregistered scan data, which is a totally different thing. A structured format, basically it has the data inside for each point organized in a particular and reliable way, right? So typically what you see is basically by scan position and then by column and by row, because there's a grid. When the scanner captures data, there's a grid, there's a polar grid to it. So that's structured data, and it's got some downsides, but it also has some upsides, which I put up here on the screen. Everybody can read. And so structured data, just so we have a visual here, this is structured data, right? So this is a point cloud in Recap. You'll see all these lovely little dots. These are all the different scan positions. So this is structured scan data.
In a structured file, just want to say there's a separate file for each one of those scans. So every single circle scan location has its own file.
Yeah.
Yeah.
Exactly. And you get these lovely little bubbles in most software where you can see kind of a 360 pano of it, right? There's also unstructured formats, which is, I just like to call it a big bag of points or a bunch of points, right? And this is, the points are not organized in a particular data-centric way. They're basically organized in a geospatial way, right? They're organized basically by voxel, which is a fancy way of saying a small chunk, geometric chunk of the data, right? And there's a lot of advantages to these formats, file size, deduplication, et cetera, et cetera. But you lose that structure. You lose those pano images and views. You don't know where the scans were taken from. And some of the, you know, for instance, some of our software, there's things we can do with structured data that we can't do with unstructured data, like automatically detect every pipe, you know, in a facility. So there are reasons to use structured data, then there's good reasons to use unstructured data. And Sylvia, in our pre-call, you mentioned that you typically provide both to your customers.
I do. Not only that, but I use both. Whenever I have to deliver a model, I like to use both. One is to optimize my workflow in Revit, because I don't want to load 120, to 100 gigs of data into my project. and I don't want to keep that maybe on my C drive. So I unify, I decimate, and I create a small file that is unstructured. That's what I use in Revit. And I pass that along to the client, and I instruct them how to use different types of point clouds for different uses. So unstructured works great in Revit, is going to optimize your workflow. Structured is great to look at, also to use for analysis.
Yeah, and so this is the exact same point cloud file, but in an unstructured format. Minimal duplication, and you can even see, just even without any kind of dedensification, the graphics performance is actually better. There are fundamental advantages to each format. So wanted to bring that up. And then there's some mixed formats. So this one is interesting, and we'll look at some actual types of formats in a second, but there's a lot of them where it could be either structured or unstructured and you don't know. So if we kind of think about terrestrial scan data as an example, right? Structured formats like PTG and PTX, they only hold structured data. Then you've got unstructured PTS, XYZ, things like that. And then there's things like FLS, the RCS format. You don't know if an RCS is structured or unstructured until you open it up. Or if you're a real geek, you can look in the file structure and look for RCC and other weird subfiles, and you'll have a pretty good idea. And E57 is the same way. And Sam mentioned earlier, structured scan data, you typically have one file per scan. E57 breaks that. You can have one E57 that's giant, but is actually all the individual scans concatenated together. So, sometimes it's easier, even though it may not be as efficient of a format, to transmit something like a PTX or a PTG if you want structured data, because you know it's always structured.
Also, Kelly, to mention, on, I think, webinar 105, we had a question from one of the attendees, and she asked, how do you remove duplicates, duplicate points? And this is something that you achieve by unifying and decimating, and obviously you're going to create that unstructured data. So that's one way of optimizing your files, is by removing duplicates. Because when you think about it, in order to have that overlap, each surface will be captured twice. So you have at least, you have the number of points needed. You have, twice the number of points needed to extract geometry or analysis. So think about that too.
Yeah, definitely. And because a scanner is a polar grid, the data over the scanner is way more dense than the data, at the equator, right? Just because the columns kind of converge together. So, there's a lot of extra data that you don't need in a structured scan. So de-densifying it makes a lot of sense unless you need that structure. So interestingly, in mobile scan data, you'll notice I've struck through the structured formats because while it is not technically impossible to provide structured scan data for a mobile scan, none of the vendors do it. And there's some reasons behind it, but none of the vendors do it. So now there's a couple of funny exceptions. RealWorks and Jexcel's software, Reconstructor, will fake a PTX from mobile scan data. So you can kind of pick a location to view the data and it will create a PTX from that location, but it won't truly be gridded. And so it can really confuse a lot of other pieces of software if you do that. So I don't recommend it. But we've actually had some customers send us structured data and then we look at it and we're like, that isn't a single scan position. That's weird. And our algorithms go haywire because they don't know what to do with it because it doesn't follow the rules. So fun little note there. But the unstructured formats and the mixed formats are kind of the same for the mobile scan data. You just won't get any structure options out of them. So they're effectively all unstructured most of the time.
So with that said, Kelly, I'm curious what question for Samantha. Like Sam, what are the most common file formats when it comes to deliverables to clients for point clouds?
For point clouds, we generally put them into recap. So they'll get a recap file, which the RCS files inside of the recap file. But we also, just like you, we usually give them both. We'll give them a structured RCP as well as unstructured RCSs for basically the same reason. RCSs work well for Revit. You can break it down into different zones and turn them on and off as needed. Less hard drive space taken up because they're smaller files. And then, so we also usually do both. And unless they specifically request a separate format, E57 is usually the most requested. Other than that, it's just a recap file. For point
okay, yeah, it's the same thing here. I don't think I've had anyone asking for any other formats than RCS and RCP in the last 3 years.
We have had people ask for, like the raw files, which we use Faro Scanner, so for us, it's an FLS file. And we have had people ask for those as well, but rarely. And I would say even the E57 file type is rare as well. Usually clients don't really know what to do with those. So the recap file is the way to go because it's the easiest for them to use. It'll load directly into all the other software that they're using.
This is like, as we talked earlier, we are removing the barriers of consuming the information, right? They do have a recap, is free or, still $100 or $300 per seat. So providing those file formats, I think is ideal. Also, another thing to note is a lot of registration software nowadays can import RCS or RCP files. So if somebody wants to bring those in for something, they can import RCP files directly. They don't need the E57 or the raw files.
Yeah, no, very true. And I will say that in markets that are less Autodesk dominated, E57 tends to be the more common deliverable. So that tends to be the in some of our European and some of our Asian markets, they can't do much with a recap file, so they prefer E57.
So Kelly, can I ask you a question really quickly? So we talked about E57 as being the format you archive your data, right? I think we talked about this about 10 years ago, 11 years ago when we did our first large project and we were kind of debating what file format we should ask from our laser scanning company. Like, is that still the case? Is E57 a format to use for archiving your data for the next 10, 20 years?
Yeah, I mean, it's an ISO format, so it's going to have backwards compatibility requirements for a long period of time. So it's your best bet for an archival format outside of maybe the raw data. So I think it depends a little bit on, and we'll talk more about archiving at the end, but the challenge with any of the exports is they don't preserve registration data. And so, I think the issue with treating E57 as an archive and then getting rid of the raw data and whatever your registration database is and everything else and just keeping an E57, you actually haven't preserved a huge portion of what defines the accuracy of a product that you deliver, which is the registration. So, I think that's a weakness in treating E57 as an archival solution, but it is an archival format. So it will protect the data from being unreadable if a company went out of business and you no longer could get their software to open the original file. So, but yeah, that's definitely a challenge. And then I wanted to toss out real quick photogrammetry because the native format is JPEGs or raw images. You don't really have the same native format stuff that you have with scanners. Nor do you have some of these kind of vendor-specific scan formats, but ultimately a point cloud delivered out of a photogrammetry solution is going to fit one of these. And because it's photogrammetry and there's actually a static camera location, you can get real structured data out of a photogrammetry solution because you can basically pick the points per pixel from the camera and you can get gridded structured scan data out of a photogrammetry solution, which is something I think most people don't think about, but there's some ways to get it out. So something to consider. But yeah, I think that pretty much talks about point cloud format. So let's transition over to talking about some alternate or more detailed deliverables or higher value deliverables. Sam, this is your image. Want to tell us what this is?
So I think this is the dome, a dome that we did a drone flight floor. Obviously, we created a mesh out of it. For us, I don't think many clients need the mesh, but it looks cool. So it's something easy to make from, we took, hundreds of photos. It's really easy to kick out a mesh once we have a point cloud made. So we kick it out and it looks really cool. And that's kind of the limit for us. We don't have a lot of uses for meshes in that context, but they look cool.
Yeah. And so, and you sent me an FBX, so I wanted to pull this up in Navisworks. This was something that we like doing on in construction for kind of logistics planning, because you could easily get meshes into Navisworks, and then you could basically use those meshes for all sorts of logistics planning, rather than pulling in a full point cloud or trying to model everything up.
Yeah, and then it is a solid, which is depending on what you're trying to do with your Navisworks file. If you are doing any kind of clash detection or anything like that, having a solid
surface
can work a lot better than a point cloud, depending on what you're using it for. So
yeah. So yeah, I wanted to pull that up. No, we don't need to save that. Thank you. Thank you, Navisworks. And I love this example because it's a little bit more detailed mesh than I think people see out of building photogrammetry sometimes, such that you actually, for instance, did that.
Yeah, so I think actually this mesh is made from a terrestrial point cloud, not photogrammetry, but that was actually, we did use this. I think we took this mesh and we put it in the Revit model, and that was used as part of the Revit model to show the detail, because that's not something that you can model very easily in Revit. So by just taking a mesh of it and bringing it in, we were able to kind of place it, make the model look finished, make it look like real life. So that we did end up using those meshes for that.
And Sylvia sent me an example that actually Paul Aubin.
Yeah, this was I think a post that Paul posted on LinkedIn a few weeks or months ago. So he's been experimenting with meshes for the last three years, I believe, and also bringing those meshes into families. So I saw this and I said, this is interesting. There's so much detail here, and I know he does great work to clean up edges and also to make these cuttable in Revit. So I think it's a great solution to combine just Revit elements with meshes.
Yeah, and in the past we've mentioned this. Revit doesn't handle meshes very well. The way to bring them in is through families, like Paul is doing here. But there are some definite performance degradation issues if you do this with a lot of stuff. So you want to do it sparingly and carefully. I think a very obvious use case is this kind of historic preservation stuff, where you want to have a very accurate, very detailed thing, and modeling that is probably not the best use of anyone's time. So bringing that in and maybe tying it in with LOD settings, so you have a more generic geometry that shows at lower LOD, and then you take it up to fine and you get the mesh. There's some good ways to manage that. Paul talks about it in his post. So if any of you don't know who Paul Aubin is, hop on LinkedIn and look Paul up. He's got fantastic classes on using Revit. So if you're wanting to learn about Revit or learn more about Revit, Paul is a fantastic resource. And of course, there's 2D CAD. It's not dead yet. I'm not dead yet. So Sam, this is one of y'all's projects. I don't know much about it.
Yeah, I mean, so they specifically wanted RCPs and floor plans in 2D from this, and we did laser scan it. So we actually never model in 2D. It's just more, it's quicker, honestly, to do it in 3D, do it in Revit. So we still model it in Revit and then just kick out PDFs as well as the AutoCAD deliverable. And but that's specifically what they wanted, is an AutoCAD floor plan. So that's what we give them.
It's funny. This sounds very similar to what architects do when they document their designs. Like, you model for documentation. You don't create the model, the 3D as being the deliverable, the as-built. You can hide a lot of things or not model a lot of things as long as the floor plans, the ceiling plans, elevations, what have you, they look correct and they're clean.
I mean, and that's one of the problems you run into with designer models, right? Is that technically it's modeled in 3D, but they're not doing it with the intention of looking at it in 3D. So they do it with the intention of making their floor plans look good, not with the intention of making it right. So you can run into a lot of problems with models like that.
Definitely. And I meant to tag, so hey, I couldn't find a good example of as-built 3D CAD apparently. Blank slide. We see this a lot for equipment. So we'll see people build kind of detailed, solid CAD models for equipment and things like that. This is one of the things I was hoping Mark would be able to join us and show, because they do some pretty detailed modeling stuff for some of their kind of plant and process work that they do, or their utility infrastructure work. It's a blank slide to remind me to make fun of Mark for not being here. And then of course 3D can, it's not just CAD, it's BIM. So this is a good example project here. We are doing Scan to BIM University after all. This was an interesting job. Tell me a little bit about this one, Sam.
Yeah, so this is for a coffee roasting facility. They're replacing some of the equipment, trying to fit more equipment in these spaces. So they just need a very accurate depiction of where things are taken up. So, we spent a lot of time trying to make these pieces of equipment as close to physically represent what they look like out in the field, so that they can figure out what they can fit in here, what they have to move around, so on and so forth. And we did it all in Revit.
All in Revit, yeah. And those, like, I love the pipe, the curved pipes modeled as segments. I have a feeling I know why it's done that way.
Because you could do a sweep, right? I mean, it's kind of like, which way do you do it? That's about it. I think we actually did that. I think that's probably flex duct or flex pipe.
Flex pipe, something over there. Yeah.
Well, I think this example is, it's a great representation of what we discussed earlier, where, if the client needs a model to run clashes to figure out how the new equipment fits in here, you give them a model. If they have the ability to use a point cloud directly to run that analysis, then they can save some money, and you can just not spend all this time creating the model. Which, the model is great, but it takes a lot of time.
Earlier we were talking about the tool we use, as-built for Revit, and that's exactly what we use it for. So we crop out a point cloud of each of these pieces of equipment, kick them out as a Revit family, and then we can make each of these into a family, which is a repeatable element. You don't have to model each one every time, or do as in place models, which take up a lot of processing power. So.
Yeah, and a lot of storage. Sylvia, this was a cool image. I like what you did here.
Oh yeah, this is just a regular project. Just a project done to document a 100-year-old building, which is in the historical registry, and we were trying to get as much detail and try to achieve LOD 300. We have some existing documentation. We had a lot of site photographs and notes, and combining all that information together, we were able to provide a full LOD 300 model. So what you see here is a section through that model. So And also this project went into design production, and all the elements that had to be modeled from scratch, let's say the windows, we had to use the client's templates, so that if they place the same window for the new design, they will be able to schedule all the information that they need for the new design. So that's actually thinking about their process, talking to them about their process, and also see who's going to be part of the design team. People within the same company, they might have different workflows.
And then sometimes things can get really, really detailed. This was having spent many years helping other people try and get railings for stairs to be correct. I can only imagine how much fun this was.
Actually, honestly, I think this was a really fun project. We had, the extra time to put into it, so we really, went deep, and you can see like we did all the cornices and everything, pretty detailed. But they specifically were interested in the railings because this is a historical building. They're trying to get, some funding in order to renovate the historical building, and so it was important to them that the railings in particular were true, so that they could show people, these are the historical railings, this is what they look like, this is why we want to preserve them, so on and so forth.
Yeah, definitely. And I love this. People can really see the detail in it here.
I love the capitals, those column capitals. Those are nice.
Yeah, I don't know who modeled that. I wouldn't be able to do that.
Yeah, it's really fun to see all these kind of detailed, more and more detailed kind of historic projects. Sylvia, we don't have a good example to show, but there's something now called HBIM where you're actually looking to, model cracks in tile and, be able to key every stone, because of course for historical preservation, if there's work done, you need to get those things back exactly the way they were. So, something that's constantly evolving is, being able to leverage these tools to kind of get to that next level of detail for things like historical preservation.
Yeah.
But let's jump to another really common one. So, in addition to modeling stuff, there's a lot of different analyses that we can run with point cloud data that's often used as deliverable. And floor flatness is a pretty common one. This is a cut fill analysis, I believe, since it's two color.
It is.
Of an office plate here.
Yeah, this the floor flatness is pretty interesting, or analysis in general. I think they're very interesting because you can present the information in various ways. You can be very graphical, like take all those images, try to create a GIF like we see here on the screen. You can present things as a list or a document, Excel spreadsheet. You just how does the client prefer to consume that information? Again, we're trying to align those expectations. So in this case, we were just trying to figure out the cut and fill to making sure that the floor is leveled. So calculating that optimal level between the cut and fill to make this floor flat before the finish goes in. Yeah.
And then, it might be something like this, just kind of describing the overall shape of it, right?
Exactly. You see the high points, the low points. And if somebody is like very savvy in tools like Navisworks or Revit, you can present this as a colored point cloud, and they can fly through it, navigate like this image, right? They can put on their VR goggles and look at it in VR if they want to. So make sure that you match those expectations.
And then Sam and Hilltip win for the prettiest slide image for the webinar. I just about fell over when I saw these. I love these. Same.
And floor flatness is fun to do, right? Because it looks cool. So it's fun to end up with something that looks as good as these do. So.
Yeah, and it's fun to see, like on the one on the left, you can really see where the structure is sagging relative to the column base and the girders and the beams underneath the slab. You can just really see how you've got each one of those little valleys of the floor. This reminds me of a project we worked on at Beck Sylview on a remodel of a law office where it like sagged 3 inches by the middle of the bay, so you could like literally pour water and you'd see it running and pooling. It was so unlucky. But
and then like the building on the right, you can see the top left corner is high or low. I don't think it's high for all of them. Low, I guess. So you can see like that is the side that's settling most likely because they're all low on that side.
Yeah.
But what's interesting is, looking at that previous slide, it's like in order to put together a deliverable that tells the story and is clear, easy to read, you need to have a degree in design or to be able to put a presentation board together, right? Because I mean, think about your architecture school, Kelly. You had like one sheet of paper and you needed to convey your ideas on one slide, one sheet of paper. So I think a lot of thought they go into some of these presentation boards or just deliverables.
Yeah, and to that point, for a lot of our scan to BIM projects, there's stuff that you have to convey to the client when you turn it over. We were talking about that wall earlier, that it's not a straight wall, but you have to model it straight. So there has to be a way that you tell them what you did, right? So we started actually making kind of like it's almost like a presentation that we turn over with it. And then a couple of these images are from those types of presentations where we say like, here's some information you need to know about the quick and dirty of what we did. And then, because there's a lot of people where you give them the information, they're never going to look at it. So you want to give them something that they can look at and actually use and learn something from, because a lot of people, maybe they have one person who's going to actually be using the point cloud, but they've got 5 people on the project. So those other 5 people need a way to digest that data. So we've actually started making we call it a report, where we give them relevant information. If there's, we don't model sags and pipes, for instance, we say like, we don't model it, but you might want to know there's a lot of deflection here or something like that. So we just try to give them information that we know is going to be useful to them, and actually make it digestible data instead of, like you said earlier, like, here's a point cloud, have fun. Like, try to give them something they can read and use and actually understand.
Yeah, absolutely. And just because we're getting close on time, I want to pick up the pace here a little bit. But we've got, there's just a lot of different types of construction focused analyses. This is just one of Sylvia's images of a dome. You don't have to do this elevation style heat map off a flat surface. You can do it on a complex surface.
As long as you have a surface.
As long as you have a surface, understand how well somebody has finished the inside of a dome to match the semisphere, right? Same thing with walls, understanding, hey, is this wall vertical? Oh no, it actually bows out a little bit over here in this corner. Same thing with these kind of more rusticated surfaces, looking at fancy architecture word for you. Understanding, okay, well, is it, how much of that variation is just the texture? How much of that variation is actually the wall leaning? There's really great ways to kind of visualize this data by colorizing the point cloud and loading that in. And then I'm going to mute this here and let this play for just a second, Sylvia. But, this also can go to, actually, Sylvia, tell us just a little bit about this. Keep it
All
quick.
right, yeah. So this was the Dickies Arena in Fort Worth, where we're right before decentering the structure. So there's some temporary towers that are holding the compression ring of this very complex roof structure. And when they're removing those towers, the compression ring starts compressing, obviously, and all this weight that's is pressing over the compression ring is gonna sag the structure a little bit, and the structure is designed to deflect. So we're trying to figure out if the structure deflects within the limits specified by the engineer. And what you see here is like a different way of consuming that information. You can consume it as a 2D deliverable or as a 3D deliverable. So here is just showing that if somebody on that team has the ability to use Navisworks, they can bring that point cloud in here in Navisworks and look at specific areas that might not have been covered in that 2D deliverable. So give them more options if they have the expertise to digest the information.
Yeah, and so that's, similarly, you can do that kind of stuff also for installation status. This is one of the things we do a lot with our Verity software is, go out on a construction site, scan when it's partially done, and be able to colorize things and know that, okay, everything that's green was installed within tolerance, everything yellow was installed without of tolerance, and everything red hasn't been installed yet. And just be able to do kind of a quick status update, quick quantities on how much work has been put in place, percent complete, all that kind of stuff. So a lot that can be done there, just to kind of understand. And then also, what can't be seen, because scanners are line of sight. You may not have a scan position in another room. So, there's also status for we don't know because something was blocking it, which is important because you want to differentiate between that and missing. Because maybe it is installed, but you just don't know. And then, of course, that extends to quality. Sam, this is one of your projects.
Yep, we do a lot of work for a client who they're leasing the space from somebody else. So it's a base build, and then they take over after that base build is done, and then they do their fit out inside. So they're very interested in knowing is everything exactly where they said it was going to be, because we need to design around it and then install around it. So we go out and we scan, and then we tell them how far off things are from where the designer said they were supposed to be or where they were going to be.
Yeah, and that's thank you for using our software for that, Sam.
You're very welcome. I actually just finished doing a Edgewise project, and I was dreaming about it. So.
Hopefully good thoughts. Yeah, and then another, looking at elevator shafts or looking at facades or other common uses of this, but also movement monitoring over time, right? Because you can basically do this kind of analysis over multiple scans separated in time and compare the results and understand if something is settling or shifting or deflecting, over a period of time. So Sylvia and I worked on a couple jobs with solar exposure, one at the National Museum because somebody built a really tall tower with really reflective glass next to it, and it kind of messed up their whole all natural indirect light thing that they had going. So, scanning, getting surfaces, and then being able to kind of project how that would impact. We've seen virtual mock-ups and virtual.
These are probably the most fun projects. Because you always try to see if the things that need to be installed they fit. So yeah, this was a project for, I think, Thanksgiving Tower in Dallas, where we created a virtual mock-up of the hardscaping. We scanned the subsurface, and then we tried to fit them together. If they didn't fit, we flagged it to the contractor, and they had to make corrections either to the design or to the subsurface. So these are always fun, and I think these are one of the most valuable deliverables because when you compare the time you spend to create this versus the time and money you save the contractor, is one of the most valuable deliverable that you can create using virtual modeling and laser scanning.
Absolutely. And then there's more imagery style stuff, right? Ortho Photos, these are basically image files that are scaled and geolocated. So if you bring them into Navisworks, they show up oriented to the facade in the exact size of the facade, but it's just a photograph. So I see this a lot in historic preservation, and they're really common in Europe. Less so here because none of us had examples of them on a project. And look at that. Videos and walkthroughs, fly-throughs, this is something that we've, very common with drones. Sam, I know this is one video you sent, just kind of a drone overview of a project that you could then use to create a photogrammetric mesh or a point cloud. And then renderings, there's that project again. And I think you said this was in Inkscape, right?
Yeah, I think so.
Yeah, so this you're gonna load it into kind of a real-time viewer, and then like Sylvia, you said earlier, do a VR walkthrough in Inkscape with the rendering. Sylvia, this is one of your renderings on a job.
Yeah, this is the same, the same historic building that you showed earlier.
And then, of course, there's animations that we can. Is this also the same building? I like
Yes, it is.
I like the jazzy music. I don't know if that's playing out in the audience there, but yeah, just all sorts of stuff like this that can really be beneficial for customers that are trying to sell an idea or a vision of a project. So, oh, look at that. Get my PowerPoint back up here, just pulled down. But I think we are at time, and I think that was, we got one more here I want to play real quick. Because this is a nice animation of a point cloud from Sam here. Same kind of thing, this is just for somebody that's not savvy in a 3D model, walking them through the point cloud, just helping them understand what was captured can be really, really useful.
Sam, can you tell us what software did you use for creating that animation?
I'm pretty sure it was the Scene video tool. So Scene has like a add-on that you can do to make videos with. I wish I could know exactly what the name was, but. Yeah,
I think it would be cool to create animations of models or render models and point clouds. If we can do that, that would save so much time to model, landscaping and hardscaping.
I've seen some people do stuff in Navisworks because you can have the point cloud and the model, and they have a walkthrough, fly-through tool and simulate. And it does a pretty good job with the point clouds, but it doesn't do it doesn't do as good of a job, I think, as Scene or Cyclone does with their video output tools, but it does a pretty good job.
Yeah, and I think the hard part with that is it's not easy to pick up. Like basically you say, I want you to go from here to here in this amount of time and this many frames. And you kind of have to play around with it a lot. Kind of time consuming to set up animations through Navisworks that way, but you can do it for sure.
Maybe one of these days Inkscape will have point clouds. And then, I don't know if Twinmotion does, but there's some of those tools have good generate animation tools as well. All right. Well, let's dive into some more questions. Real quick from Byron Joyce here. How do you create a floor flatness report from your scan files? So I think Sylvia, why don't you could you two mention the tools that you use one more time for that?
I personally use Built-It from Faro, and I'm currently evaluating 3DR from Leica. So my workflow is to, instead of creating an analysis directly in Cyclone, directly in Revit, like I used to do about 10, 11 years ago. Now I like to create that analysis in a third-party software and then bake the heat map into the point cloud and be able to bring that point cloud into any tool of my liking to document the analysis.
Yeah. And we use As-Built for Revit, which is a Faro software, and then we've also used Rhythm. And the difference is what Rhythm is with that you can actually do an ASTM floor flatness analysis, which is important to some people. But really, you don't need a third-party software. You can kind of mock up a floor flatness type contour, maybe not map, but you can colorize point clouds in Recap, in Revit, in AutoCAD. Back when I first started this, we used to do our floor flatness in AutoCAD by colorizing a specific, range of the point cloud. So you can get those images and information. But if you want it to come out nice as a contour map with, you know, the that bar on the side, you're gonna probably want to get a third-party software to do that for you.
And those, you know, the heat map is not baked into the point cloud. It's just a
Right.
visualization.
Yeah, what's nice with
setting.
the tools that
Yeah.
we use is that you actually have a surface and they colorize the surface. So it's not the point cloud anymore. It's actually a flat image that they use for the point cloud to make. Whereas if you colorize the point cloud, you're still just looking at a point cloud.
Yeah. Indeed. Awesome. All right. What are the presenters' opinions on MicroStation and Bentley products, from Phil Gleason?
I mean, I used to use MicroStation before I was doing laser scanning and stuff. I was actually a bridge engineer, so we did all of our drafting in MicroStation. I've not done any integration between MicroStation and laser scan, so I can't really comment on that.
Yeah, I don't have experience either. It's just Autodesk products.
Yeah, I mean, for civil projects, flat work, you know, they're the Autodesk, right? For horizontal construction, Bentley is Autodesk in that space. So they've got a good point cloud engine. They've got their own tools to bring it in, their context capture, which will, you know, load in point clouds from scanners or photogrammetry and get them as meshes and then pull them into their various different applications as meshes, actually. They prefer to work that way. But I think you can load them in as points too, but not an area of expertise. But since TopCon owns us, they do a lot of work with Bentley and MicroStation. So I know just a little bit about their stuff on the horizontal construction side. But if you're doing that kind of work, and they certainly have solutions to work with it. I think you go through context capture though, as opposed to going through recap like you do for Autodesk products. Awesome. Robin Frost wanted to know how he can learn, or she can learn to do Revit models like the coffee roaster project. So
we do training.
There you go. Look at that. Nice plug, Sam. Scott Lochner asked, they'd like to know the workflow on the 2D plan that you showed, Sam. And I believe what you said is you modeled it in Revit and then just made plans and RCPs from the Revit model, correct?
Yep, correct. And I would say for that specific project, we did not go too in depth with the 3D space. So I mean, like if it was a wall and then we had we wouldn't model soffits, for instance, unless they were shown in a plan. Or like an RCP, but yeah, modeled it in Revit and then exported it out for AutoCAD.
Yeah, awesome. I'm gonna type that down. But yeah, that's I've seen a lot of people do that actually. I know one of our other presenters, they do a bunch of retail work. Where they'll go in, scan, do a quick, you know, only model what's needed, and then, you know, crank out these retail 2D floor plans in AutoCAD, and they just hammer through those things super fast.
I mean, for us, we use Revit almost exclusively for modeling, right? So it's kind of like it would be a learning curve for us to learn how to do the same thing in AutoCAD. It's been a very long time since I've really modeled anything in AutoCAD, so it's just faster and more efficient. And I think you also have the 3D model at the end of that. Like, we don't keep that for ourselves. We also give it to them. So maybe something comes down the line where they are going to need that and they're going to use it.
Yeah. All right. John Sanchez, yes, we can do floor flatness reports in ClearEdge software. So Rhythm does, Sam mentioned Rhythm. Yeah, we have Rhythm for Navisworks. Anything you get into Navisworks, you can take into Rhythm, do ASTM reports, contours, grid of points, all the stuff that Rhythm does for floor flatness, including colorized heat maps, contours. So definitely can generate all that stuff there as well. And then on the, like what Sylvia showed with the beams, and I think Sam had an example as well. in Verity, if you use Verity to test stuff, you get a colorized heat map for every object that you test as well. And you can export that out as a point cloud that bakes in the color map and bring it in. So all sorts of stuff you can do there with our software as well. But there's, fortunately, there's a lot of things to choose from. So kind of depends what your stack is, which software probably is going to work best for you. Let's see, and follow-up question on floor flatness. Is the report certified to go against the dipstick and D meter? Sylvie, Sam, do you guys have a take on this? I have a take on it, but
it's a different thing when you do just a flatness analysis versus a flatness and levelness. I mean, those are, you need to meet certain criteria and specifications in order to produce those reports, and you use different tools for that. So what we showed, I don't know if Sam had any levelness analysis, but what we showed was just flatness, not levelness. And I mean, I haven't tested to see if our results when you do flatness and levelness reports are more accurate or less accurate than other methods of measuring. So
when you use rhythm, it's because we need that ASTM report, which is that's when the same thing as the stick thing. I've never seen anybody do it, but it's been explained to me. And basically, you're doing that but digitally. So you're setting those lines that they would be doing out in the field and digitally doing the same thing. I know that our clients have accepted it. I guess I don't know the official answer, but for us it works.
Yeah, I mean, it's one of these things where it's a really tough thing to compare against, because I guarantee you, if you have a guy or gal go out to a job site and run a dipstick, try and get them to get a repeatable result on the same line. They can't, because you cannot walk a perfectly straight line with a dipstick and have the thing land on the exact same spot every time. So I've seen massive variation just depending on them walking the same run 3 times. With the actual physical device. The same thing is true if you draw a line ever so slightly different in these digital tools that replicate the process. You're going to get slightly different results each time. That's because you're actually sampling different data each time, just like you are with a real dipstick. So it's the ASTM 1155 standard does now allow for the use of scanners to replicate the process. There's some guidelines and stuff on it, and I'm not super up to speed on it. I certainly recommend talking to the people that are core to that standard, who publish that standard, to kind of understand the scope and state of that from a legal standpoint. But I think the bigger thing is, if you're talking about the dipstick, if you're talking about the D meter, if you're talking about any of these things, I actually think the bigger problem is that they're terrible ways to understand how flat a floor is, because you're characterizing an entire floor by sampling like less than 1% of the entire floor. And just think about that, right? You run lines, but you're sampling a little 2-inch circle every foot roughly along that line, and that is characterizing the entire floor. So one of the things we saw all the time as a contractor, when somebody would go out there and run it, if they got a failing test, they would just walk back to the start of the line and walk it again slightly differently. And they do it 3 or 4 times until they passed. That's the test, right? That's a terrible test. You try it again until it works. So that's a sign of a horrible standard, right? And I don't mean that to point fingers at anybody. It was the best thing that could be done prior to laser scanning. But now we have something that samples 100% of the floor almost at a super tiny spacing. The reality is a contour map or a color, elevation color map is actually a much more robust, much more complete way of describing the flatness and levelness of a floor. It's just not an accepted standard. So, I think the bigger effort is trying to take advantage of technology to have standards that actually do a better job of characterizing how flat and level a floor is, rather than trying to replicate something that is actually not a very good mechanism of doing so. But that's the challenge when you have these standards. Standards are built on old technology, new technology tries to fit into the box, and maybe the standard actually needs to be updated. But that's my opinion. Off my soapbox. Let's see. Great question. If floors, beams are sagging in most places, what should our best approach be for modeling them? Should we model them flat or follow the deformation? Sam, why don't you start us off with this, and Sylvia, I'll tag you in.
I mean, I think it depends on the goal. Like if they're trying to document that sag, then you need to document it somehow. So is it that you model it, or is it that you model it flat and then do an analysis on it to say what the deformation is? For us, most of our as-built projects, we specifically say we will not model sag. But if we notice it and we see that there is a significant amount of sag, we will tell them. So we'll say, this line sags up to 4 inches in the middle. We've modeled it straight. You're going to want to check that out. So yeah, I guess it really just depends on why you're doing it. I know for a recent structural job, they were trying to document that type of thing. So what we did is we modeled the generic way, and then we actually did like a section of each, they were trusses, and we said, look, here is how it differs in this specific location. So yeah, it's one of those things where it's like, what are they trying to do with it? And then you have to decide how you're going to model it. But generally, I would say we do not model deformations or sag.
Yeah, it's the same thing here. So I think first thing is the tool that we're using to model these as-built conditions. They're not designed for this. They are designed for new projects. So basically a beam or any other structural member is defined by 2 points, 2 ends, which is a straight line. So if you're trying to do it otherwise, you need to use a generic object like Samantha says. And but the way we do it, we try to model everything straight, and then if we have a lot of deformation that's outside of a specified LOA level of accuracy, then we're going to flag those elements, and those will be shown in the final report. But then you might be asking yourself, how do you model, or how do you fit a flat element, a straight element, to an element that's sagging or is deformed? Do you try to do an average, or do you try a different method of fitting that element to the point cloud? My preferred method, since my background is in structural engineering, is to fit the structure element using the supports. So I'm using the elevations at the supports, the other ends of a beam, let's say, and I don't care how much it sags in the middle, as long as I match the supports. Because otherwise, your project is going to be a mess if you're trying to do a best fit or an average of that deformation.
Yeah, it's one of those things where it's like there's kind of a level of abstraction that makes sense for certain elements, and it's different for walls than it is for beams than it is for columns, but there's kind of a way to abstract them that makes a lot of sense. And then there's actually modeling exactly what's there using something like a mesh or something like that. But trying to be in the middle of those things can get really, really challenging. It just gets really hard to kind of navigate all the different compromises you have to make on all the different sides of everything else. So, there's kind of strategies that you learn for each type of element. For this is how you abstract them when you're doing scan to BIM. You optimize them this way for a wall, and this way for a beam, and this way for a column, because where they connect to other things and how they relate to other things, and you have to kind of make intelligent choices there.
And also, Kelly, I think for structure is a little bit more complicated because you do want to have a somewhat connected structural model. and you don't want, a column, let's say, run higher than your beam. So
Yeah.
you always need to make those decisions, yeah, to make sure that you're using the supports when you're modeling elements.
Yeah, absolutely. Sam, what software did you guys use to convert the point cloud to mesh?
I can't say for sure, but I would say maybe Scene for some stuff, or if it's photogrammetry, generally we use Pix4D. We don't get too into meshes, so I can't say if there's something better than that.
I used two in the past that worked pretty well. One is Recap. They reintroduced, I believe, Point Cloud to Mesh. You need to just buy credits to use it. And the second one is Scene 2. And,
yeah, actually, I was just thinking that. I was like, I think Scene 2 does it now too.
Mm-hmm.
Well, it always
And,
does.
you mentioned 3DR. They also have pretty robust meshing tools in 3DR. And then for a freemium tool, there's always Cloud Compare.
We've used that before too, actually.
Yeah. Yeah, and that you can try for free. If huge things won't work very well, its robustness is not quite up where some of the professional paid software is, but for smaller stuff it works fantastic. And the price is hard to beat. All right, a couple more, one or two more. Let's see, I think we already answered that question. It was Pix4D. For TLS scanning, do you still use targets or do you go targetless? Also, do you use survey control points to ensure accuracy? Quick shout out to our prior Scandinavian University sessions where this is covered in detail at various points. So if you have questions on this and you haven't seen some of the prior sessions, this whole series that we've done over basically since the start of this year have been walking through the process step by step, hence ending on deliverables. And so if you go back to some of the earlier ones on field practices or some of the earlier ones on registration, we talk about target versus targetless, cloud, cloud to cloud registration, all of that kind of stuff, very much in detail. So let's not dive into that here. And I think, trying to see if there's anything else relevant.
And if someone watches the previous webinars and maybe we don't answer your specific question, feel free to just send us an email or a message on LinkedIn, Twitter. We'll be very happy to answer your question or help you with your problem.
Yeah, I mean,
free of charge.
Free of charge. That's right.
Sorry, just that's how we spend our free time. It's fun.
And that's how we learned, is other people helping us.
Yeah,
so
exactly.
Got to pay it forward. But yeah, hop into the Scandinavian University LinkedIn group. If you haven't joined it already, join it. Post questions in there, and let's crowdsource your answers, because Sylvia and Sam are both brilliant and have tons of experience, but we've got probably 15 different panelists that have been on all of these things that are part of that, and then there's all the other experts that attend and watch. And so it's a great resource for getting your questions answered by all means, or reach out to people individually on Twitter, LinkedIn, wherever. Is there a way to convert a mesh into a Revit model, specifically elements? And why are meshes not used as masses to use as a base for Revit modeling? The second half of that question, Pavan, you'll need to ask the brilliant minds at Autodesk why they did what they did. I don't think we can answer. But the first part of that question, I do not know of any way to convert a mesh into a solid object in Revit. I mean, meshes are inherently not solid objects. They're just surfaces. Sylvia, Sam, do you guys know of anything?
I mean, I wish I could invent the solution to this. I think
and
everyone wants to invent
like
that.
a workaround. You could use like a 3D printing software to make it into one, kind of. I don't know. That's just off the top of my head. I'm like, maybe, I don't know.
That's actually good, because there are tools for 3D printers that focus on taking meshes and turning them into solid so that you can 3D print them. So yeah, that's actually, I think that's probably a logical hack. But yeah, as far as I know, you can bring meshes into the family editor, as we mentioned earlier. Buyer beware, you do that a lot, your performance will suffer greatly. But though it is getting better. We have an audience member tipping in that, thank you, Mina, saying Rhino can work for mesh manipulation if they're not massive. It's a great point. Rhino does have some mesh editing and closing cool tools. I'm also from Josh, Tinkercad, Inventor, Mesh Labs, Mesh Mixer. All of them will turn into a solid, so more on the manufacturing side. Tools I typically see more on the manufacturing and product side, but yeah, you know, for doing a one-off family and getting it into something like that, it's a lot of manual work. There's not a push button solution, which I also suspect is kind of behind the question. Is there an easy way to convert it? I think the answer is no. There's a lot of hard manual ways to convert it. But yeah, and thank you for the audience chipping in there. Good job, y'all. Yeah, with that, let's wrap. We've got a couple other questions from that are answered in other ScanDiVim University classes. We'll follow people in due time. Watch the ScanDiVim University LinkedIn group. And otherwise, thank you, Sylvie, and thank you, Sam, both of you, for participating and sharing your wealth of knowledge.
It was my pleasure, like always.
Thank you.
All righty. Well, let's wrap it, and yeah, look for that recording to become available in a week or two. If anybody else wants to watch, just tell them to go to the ScanDiVim University, www.scandivimuniversity.com, and register. That's the same way you can look at older classes. Hop in there, register for one of the older classes. You'll get the recording, and yeah. And that is the end, I think, of this series, excitingly enough. So we'll have to see what happens next. But yeah, thank you guys. Thank you,
Kelly.
audience. Bye.
Have a good one.